This video explains how to use Rockwell Automation's device libraries in Studio 5000 Logix Designer. Use these methods to correctly import and configure device object add-on instructions and modules for use with HMI faceplates. I'll be demonstrating the use of some specific devices, but these steps generally apply to objects from all of our device libraries, including power, I/O, networks, safety, I/O link, and more. The instructions in this video assume that you are already familiar with the basics of Logix Designer and already have a project created. Now let's get started. In this video, we will cover downloading device libraries, importing device add-on instructions using either the import library objects plugin method or the import rung method, interfacing with device AOIs in your programs, and updating AOIs to new versions using either the import library objects plugin method or the import AOI method. Feel free to jump ahead to a specific chapter. In case you haven't already done so, you can download any of these device libraries for free from the Download Center on rockwellautomation.com. Just search for device library. First, I want to explain that there are a few different ways to import the device library code into your Logix Designer project, and it's important to choose the right option. A couple of these options require an additional software installation. Studio 5000 Application Code Manager is a free piece of software that can be used with these libraries to really speed up implementation. Think of it like an extension to Logix Designer that allows you to shift your mindset from traditional programming to bulk project configuration. If you don't have this yet, consider heading back to the Download Center on the Rockwell Automation website to download it for free. If you already have an existing project that you want to add a new device object to, there are a couple main methods. Option 1, if Studio 5000 Application Code Manager is installed, you can use the Import Library Objects plugin to call up a wizard to configure the import. This option is great because it can also create and configure the module in your I/O tree, and it takes care of a bunch of tag naming conventions for you automatically. Option 2, you can import the provided rung.l5x files directly into a routine. This just requires a little extra work to manage your tag names and also means you have to manually configure the device module in your I/O tree yourself. Another deciding factor might be whether or not you can take the controller offline to do these changes. Only the rung import method can be done with an online controller, as long as you aren't migrating any existing add-on instructions to newer versions. Okay, let's start by looking at the first method using the Import Library Objects plugin, which requires Studio 5000 Application Code Manager, often called ACM, to be installed. Before importing any new devices, the library needs to be registered. Find the setup command file in the root folder of the library files and run it. This will register all of the library objects with ACM automatically. Close the script window once it is complete. In your Logix Designer project, just right-click on any of your tasks and go to Plugins, then Import Library Objects. This launches the Library Object Import Wizard, basically a light version of ACM right here in Logix Designer. On the left, you have your list of registered libraries. This will include any libraries that you downloaded and ran the setup command script for. The RA-lib device folder includes all of the Rockwell Automation device library objects. Within this folder, the device subfolder is where you will find most of what you need. If you have registered multiple device libraries, you will see these categorized into more subfolders like I/O link devices, power discrete devices, network devices, and more. For this example, I will open up the power velocity folder and just drag a PowerFlex 755 drive into the window on the right under library objects. You can choose to drag in multiple instances or multiple different devices and configure them all in a single import if you want to. Now in the Object Configuration window, you will see a list of parameters that can be configured for the object. Not every device will have the same parameters here, and it's best to refer to the appropriate device library's reference manual for details about specific devices. That being said, a number of these parameters are pretty consistent across most devices. Start by entering a name and description in the top. The name will be the name of the add-on instruction or AOI instance. The description will be entered into the AOI tag's description metadata field. Put something brief but helpful here because it will be seen in HMI components like the graphics symbols and faceplate window titles. I'll call this Pump 100 device for my intake pump VSD. Use the drop-down menus to select the task and program that you want to import this latter routine into. Then jump down to the tag scope parameter. You can choose to create either program scope or controller scope tags depending on your preference. For some power device objects, there is also a parameter for object interface data type. If you got a plant PX5 system with a P controller, then this needs to be set to predefined data type with controller scope tags. And don't worry, all these parameters have descriptions at the bottom when you highlight them. Most devices also have module parameters. If the include hardware parameter is set to true, this wizard will automatically create and configure the device module in your controller I/O tree. Alternatively, if you already have your module set up, you can set that to false, but you will need to make sure the module is configured with the required device definition that's outlined in the device library reference manual. You will notice that a standard module name has been generated by adding mod as a prefix to the AOI tag name. You can change this if you want, but just make sure not to name the AOI and module the exact same, otherwise you will have issues later on. In this section, you can also define the IP address, the parent module, meaning the name of the Ethernet adapter, and any other hardware configuration specific to this device type. There may be other parameters to fill out that vary from one device to another. Anything from extensions, sensor configurations, specific catalog numbers, or other details required to customize the import. The HMI configuration parameters can be ignored when using the wizard. These are used only when using the full application code manager software to generate pre-configured HMI content. Refer to our application code manager video for more details on that. Now that all the parameters are completed, click the Linked Libraries tab. Just use the Auto Create button on the right to generate all of the other required items associated with the latter import. Then continue by clicking Next. These steps are just showing you all of the changes you will be making to your program and may give you an opportunity to make special choices, like skipping or overriding specific components. In most cases, you should not need to change any of these settings and can continue until you can click Finish. Once the import completes, you will see the module has been added to the I/O configuration tree with the required device definition. A new routine has also been created with a rung that includes an instance of the device AOI, and it has all of the required tags and references filled out. For most devices, your code should compile without any errors right away, and we're all done without any real programming. It was that easy. Next, let's take a look at the rung import method. This option is great if you need to add a new device object to an online project or if you just don't have application code manager installed. It just requires a bit more attention to detail. Before importing any logic, you should have a module in your I/O configuration tree. For this example, I have added an Stratix 5200 series managed switch. Some devices require specific device definitions in order to work properly, so make sure you take a look at the device definitions section of the library's reference manual for any unique steps for your device. For example, many power devices need special data link parameters configured. Again, this step is not required if you instead use the import plugin method with application code manager. Start by opening up the routine where you want to import the device object rung. Just right-click on the left side of the ladder and select Import Rungs. Navigate to the place where you save the device library files. By default, this is the RA folder on your C drive. Inside the library's root folder, open the folder called Studio 5000 Logix Designer Files. In the case of the power device library, you might have to go one folder deeper and select either the standard files or the plant PAX specific files. Now in here you will see both rung import files and also AOI or add-on instruction files. You might be tempted to just import the AOI files and create your own instances from scratch, but these should really only be used for updating AOIs from an old version to a newer version. Importing the full rung files ensures that you also get any additional required code. Tags like default lookup array and naming conventions are followed. Alright, select the rung file of the device you want and click Open. For this demonstration, I am selecting a Stratix switch device. In the import configuration window, go to the Tags page. Use the Find and Replace function to replace the underscore instance name with the name you want for the AOI instance. Depending on the device, there may be more tags here called mod underscore instance name referring to the module name. Once again, use Find and Replace with your own module name. Otherwise, go to the Other Components page and browse for your existing module for any remaining missing references. There should be no more red flags before you hit the OK button. The run including an instance of the AOI, and all of the tag and module references should now be imported and ready to compile. Now that you have all of the code in your project, let's take a look at a couple other things. First, you might be wondering how you can integrate your own programming logic with these device instructions. Most device AOIs have what are called interface tags. In the AOI, these parameters start with ref control in their name, and the associated tags normally end with something like control set or control command. There are 4 interface types which are commonly used. Command, status, settings, and information. CMD, or command, is your command interface to devices with output control. With a power device, you can use this to do things like activating or jogging a motor. With an I/O link sensor, you can activate the locate LED. If the device supports it, you can also find commands to switch between physical and virtual modes here. It's important to note that if a device module is connected to a device object AOI, you should only control it from these tags. You should not try to write directly to any of the module's output tags directly if they are already connected to the AOI. You will also notice that if you are using power device AOIs along with plant PX or machine builder instructions, they will write directly to these tags as the control interface. STS, or status, is your device status interface. Inside, you will find standard status information like faults or warnings, the device's connection status, and other key values or states for the particular device class. You might consider using members of this interface to trip alarms, interlocks, or permissives in your program. SDT, or set, is your device settings interface. If a device has settings like a drive's speed set point or a sensor's trip set point, you can programmatically interface with them here. This interface also commonly includes settings to inhibit commands, settings, or configuration changes from the HMI faceplate. It's worth noting that when power devices are connected to plant PX or machine builder instructions, these inhibit settings are all turned on since the motor or VSD instructions are then in control of the device. INF, or information, is used for some devices to pass information between different instructions, like a power device to an extension object, a safety device to a safety group, or an I/O link sensor to its master. In general, you should not have to interact with this interface yourself. Before we wrap up, just a few notes on library object upgrades. New versions of device libraries are regularly released, and in some cases, you may want to migrate your existing AOIs to newer versions to take advantage of new features or to address anomalies. You can do this either using the Import Library Objects plugin with Application Code Manager installed, or by importing the provided AOI L5X file. With both methods, the controller needs to be offline. If you want to use the Import Library Objects plugin, access it by using the right-click menu on your controller. In this case, rather than opening the device's folder, look for the Asset Control folder. All of the objects in here include the components associated with the device object like the AOI and tag definitions. Select the new Asset Control object that you want to migrate to and drag it over to the right. Now in the Merge Actions dialog, you want to make sure that the Overwrite action is selected for any components that you want to update. If you want to use the AOI import method, right-click on the Add-on Instructions folder and select Import Add-on Instruction. Find the appropriate AOI L5X file from the Studio 5000 Logix Designer files in the library files and import the updated version. Make sure to choose the Overwrite operation. With either of these methods, in some cases like major version updates, there may be additional steps required like reassign tags if parameter names or data types have changed. Refer to the device library's reference manual for details if you are unsure. You will also want to ensure that the version number used in the HMI faceplate and the AOI match, otherwise the faceplate may not be able to open. If the HMI faceplate has also been updated and includes a new version number, follow these steps. Find the affected add-on instruction and open up its parameters in local tags view. You can filter on the inf_lib tag to see the default value used in the new AOI definition. To update the existing instances of the AOI, click the small arrow beside the Copy Values button and select Copy Specified Values. On the left, deselect all tags, then select only inf_lib. Select all of the tag instances on the right, then click OK. You can confirm that these have updated in the instances by using the Data Context drop-down menu. The updated AOIs and HMI faceplates should now work together. You should now have everything you need to get started with the device library objects, and they can be connected to any of Rockwell Automation's supported HMI platforms. Check out all of our device library videos for more information and tutorials, and download all of these libraries for free today from Rockwell Automation's Download Center at rockwellautomation.com.